Hello all, welcome back to the SAS learning sessions. My name is Naga Vimprala. In the previous sessions we have seen how to perform a univariate analysis, statistical hypothesis testing on one variable. Today we are going to continue on uh, a little about univariate analysis and also another hypothesis testing, which is tTest. For that, I have created a small case study kind of thing on car sales. Okay, I named it as a project 1 in the library name as project 1, and I am saving it under one particular folder. This is the folder on my SAS Studio. The data that I am taking for this cars project is from SAS help library, and it is having a car ID, and I am just uniquely giving a ID for it. Another one is these cars whatever are listed in SAS help library, they are being sold by two different stores from Miami and Las Vegas. To capture the sale amount or how many units have been sold, I just repeated this particular uh, repeated it to some 428 records for 12 months. During the 12 months duration, on each and every card I have 428 records in the cars dataset. So I'm capturing how many units are sold per month for that particular car model. For this particular purpose, I am using a absolute value from this random. It is taken with the parameter of uniform distribution, and I'm going to capture an integer value, and it is an absolute. So here negative values are also possible, so I'm using the absolute value. And the seal gives me basically the highest integer value. Whatever is the random that I I get, it will be a number in between 0 to 1, and it will be having decimal places. So I just multiplied it with the 10 and took an absolute value and taking the highest integer value. So mostly I will be getting everything more than at least 1 unit sold. Likewise I did for the second store ID. So as I have taken two stores here, because for current session we are going to cover tTest. So what exactly is this tTest? Okay, tTest is basically a statistical test performed on two population means. So to perform a tTest, I should have two means, and I want to check if the means are different, or there is a significant if the means are significantly different, or if the means are equal. We have previously seen PROC univariate with a mu naught. What does that mu naught say is it's a benchmark value, and as per the hypothesis, null hypothesis says that the benchmark value doesn't deviate much from the means calculated out of the sample, means calculated out of that particular sample. That is the null hypothesis. And if at all, if it is going to change, or if it is going to deviate at a particular confidence interval level, then we are going to ignore that null hypothesis, and that is the alternate hypothesis. Alternative hypothesis says yes, there is a significant difference in the benchmark value when it is compared against the means of a sample. So here also we are again going to consider this hypothesis testing. So t-test is also called as a hypothesis test. Here a particular example is given. This is taken from Investopedia. A t-test could be used to compare the average floor routine score of US women's Olympic gymnastic team to the average floor routine score of China women's team. So here we are comparing two means. One is US women's Olympic team and the other one is China women's team. This is a two independent sample t-test. So what are all kind of t-tests we have? We have two different type of t-tests. One is one sample t-test, which is nothing but the same univariate analysis, as we have a means here and we have a benchmark mean. That is the mean which we are going to compare it on the sample mean at a particular confidence interval. So this one sample test is an univariate analysis, and another t-test is two sample t-test. If the two means that we are considering are independent of each other, then we go with the independent two sample t-test. But if there is a dependency of another particular factor, like if the sample of observations whatever we have received at one point of time is a little different from another point of time, so there is a time dependency, then usually we go with paid paired sample t-test. So these are the different kind of t-tests we have, and the assumptions for this particular t-test. Assumptions are, as I have mentioned, for whether we are going with a one sample t-test or an independent sample t-test, the samples we are considering are random sample purely taken without any bias, and they are independent and without any association. Association is nothing but it's a factor on which the outcome is depending. So we don't have any associations here. And the second assumption is data is normally distributed. So then only our statistical functions will be accurate, or descriptive statistics whatever we gather out of it, they will be accurate if the data is normally distributed. And third one is variances of the two samples are equal. So standard deviation squared 1 is equal to standard deviation 2 squared. We have let's assume that all the assumptions have been met, and moving on to the SAS session. So after creating the data, now I am what I am going to do. Let us define like what exactly we are going to do. Here our thing is, first one we are going to see how we can perform a univariate analysis using this t-test. For that, verify that the probability of selling $175K worth of cars in 2016. So let us assume, okay, let's assume it as 2015 for now. How much close each store, how much close each store is per month basis for the benchmark that has been set for that particular store, which is 175K in dollars. This we can do. First of all, if we see the cars data, the cars data has just the car models, and I have calculated a new column, car ID. And the car sales has how many units have been sold for each and every card. So what I am missing here is the sales value. So sales value is units sold into the invoice. Okay, here so I am sorting the data set and then calculating the sales, which is nothing but units sold into invoice. Let's run this code. Yeah, we got the units, we got the sale price, sale price for each and every model. What is the output? The output is car sales. Looking at the car sales, we have yeah, the sale value invoice into the units sold. Now I wanted to check the benchmark value against the means for that particular store ID and Sale date is per month basis. So I have two categorical variables here: the store ID, the sale date, and the variable under analysis is sales. So this is the regular procedure that we do using PROC Univariate. So let us run this, and here using this ODS select, I am just selecting the moments, test for location, and histogram. There are we have previously seen there are so many other outputs which Univariate generates for us. Those include extreme observations and tests for uh, normality, other things. Okay, but here we are going to check only the moments, test for location, and histogram. Okay, PROC Univariate, it has created the output for us, and based on each store ID and the sale date, we got the the moments calculated, and then the test for location is performed, and finally we should be seeing a histogram. Here histogram is there for each and every store ID. So this is the regular process that we know how to how to do a univariate analysis using PROC Univariate. But in order for the univariate analysis to be done using a t-test, it's a one sample t-test, we have to capture the dataset individually. We should not be passing any class variable in case of one sample t-test. The variable should hold only the values by group, by that particular store ID and sale date. So for that, what I am doing is, yeah, using one sample, I am performing a one sample t-test to check if the car sales by month are anywhere close to 175k. That's the target set for that particular store by month. It's an example of t-test. A new concept I have here, till now, which we have not discussed. It's a SAS concept, macros. I am creating a store ID. It's a sorry. I am creating a store IDs. It's a macro variable and sales dates, and it's a global variable. If we are creating it outside the data step, it's a global ID, and I am capturing the distant store IDs into this store IDs macro variable, separating it based on column. So likewise, the same thing I am doing it for sale date. So I should be getting. Let us run this code. Yeah, these are the results. In the results tab, we have the unique values. In the log, we should be having that whatever the SQL that is run. So let us print this data variable. We will be able to print macro variables using a percent put. So these percent statements are macro statements. Percent put store IDs, and as it is a variable, we have to give the macro variable followed by a ampersand. Same thing I am doing it for. We can have it in the same single percent put statement, but I am giving it separately. So two lines on two lines, we will be having the values displayed. So let us run this two put statements. The store IDs, it's created as each store ID separated by a column. The same way, all the 12 dates, they are separated by column. So now I am performing a t-test. I am again doing a little more into macro coding here, where I have written a small macro. It's a t-test macro, and I am calling it here as percent tTest. Usually the macro, when we are creating, it should start with percent macro tTest. Macros are nothing but functions in SAS. Okay, so I'm creating a macro here for each and every uh, I'm sorry. I'm creating a macro here, and I'm executing the macro with the just macro name. I'm not passing any variable or anything to this macro. We will discuss a little more into the macros when we separately deal with these macros in the further sessions. But for now, just it's a macro I have created, and percent let it's a to declare a particular variable inside this macro. I am declaring a new variable stores, and I'm giving an integer value using this percent eval. The stores will be holding a value of 1, and I'm looping it till the stores scanning till the scanning of the stores variable is done. So I'm scanning for next uh, column. So the first one will be getting the first store ID, and when the next loop continues, we get the second one, and when there is no more, it should display nothing, and then the loop should end. So until the loop ends, we are going into the loop, and I got the store ID captured into store ID new macro variable store ID. So I am displaying it here, and the value I am displaying in the incremented value. So here I am not incrementing anything, so it should display 1 for the first time, 2 for the second time, like that. And we have two store IDs, so 2 times this person put statement should be executed. The same way I am doing it for, I am doing another loop within this particular loop um, to capture the dates. The 12 months, so it will be executed for 12 times, and the dates value it will be incremented 12 times, and sale date will be displayed. So here I am after capturing this, I am incrementing this dates value, and this is the t-test value, t-test data set that I am going to perform t-test on. What I am doing is, as the t-test has a limitation that if we are planning to perform a one sample t-test, there should not be any class variable used. So only the analysis variable should be under consideration. Just it's a plain vanilla t-test. So to do that, I am getting the records for that particular store ID for each and every month. So this data set will be executed in loop, and also the same PROC t-test. So it's a simple PROC t-test I am performing to verify that the benchmark value of 175,000 against the average means of sales for each and every store for the respective month, and I am calculating at a confidence interval of 90, and after that I am incrementing this store, so the same thing will be performed for the second store. Let us run this piece of code and see how our t-test result look like. Okay, so here we got the t-test calculated. We don't get any moments, and we don't get anything like moments in detail, kurtosis, skewness, coefficient of variance. Those things we don't get it out of t-test. T-test give exactly what is minimal required for our understanding. So here we got some mean, standard deviation, standard error, and minimum maximum, and at confidence level of 90%, what is the lower limit and the upper limit. So as we can see, the 175k is between the lower limit and the upper limit. So our probability is greater than 0.1%, and we cannot ignore the null hypothesis. So for this case, during the period of January for store ID 103451, there is no much significant deviation of the sales, the benchmark from the benchmark value of 175k. So here if we see the t value, it is between, it is minus 1.03. So here it is a little, it's a negative value because the benchmark value is towards the right side, but um, there are more values towards the left side. So we got a little negative value. So we can verify this thing. We can verify this thing from our graph. Previously we have seen that how the normal distribution is. Okay, this is the bell curve we have. So let us look into this particular value of minus 1.03, where exactly this lands. Okay, here we have math is for fun. In this the interactive bell curve is there. So here we got a value of minus 1.03. So roughly it's here. So at a confidence interval of around 70%. This is 34.85 on the left, and on the right if we take. So overall this area will be bound around 70%. So we need not even go till 90% interval. With 70% interval itself, this is calculating. So here we are going to consider even more values if we go a little deep. I mean, if we go till 45%, okay, roughly around here, we can say almost whatever is the value that is deviating till minus 1.6364, we can say that at 90% of the 90% confidence interval level, with that confidence we can say that the mean, probable mean of the sample could land between this area. So we are well within this particular limit. So obviously we can say our null hypothesis stays. So the sample mean is not deviating much from benchmark mean, that is 175,000. So this store is doing good for the month of January. Even we have the QQ plot drawn from PROC test. The same way we can verify for February month. Again, the probability is even better, 0.57, and the t value is very less. So this is also very much fine. So likewise we got this particular t-test calculated for almost not almost for all the 12 months for each and every store. So in total we got 24 graphs drawn for this particular uh, t-test. So using this macro, we are repetitively calling this same t-test, and we got the values displayed like the way I have shown here. So the title statement says one sample t-test for this particular store and this particular date. That is what I have given in the title statement. This is a ODS statement. So for the display purpose, and our macro variable is displayed here. So each and every time the loop goes on, this particular value will be resolved appropriately based on this scan output, and the same way sale date is resolved based on the um, value here, the sale date. Here we are scanning it and displaying it. That is the value that we are displaying here. Now we know how to perform a one sample t-test. Let's move on to two sample t-test. So here we cannot perform a paired t-test because they are completely independent samples. If we go and take any dependent samples, then we can't go with the independent sample. We have to perform a paired sample t-test. So how we perform a paired sample t-test is we have to include a star. That anyway we don't need to worry about it because we have an independent sample here. So on this particular variable sales, I am performing uh, two sample tTest. So, for example, if we have two different samples like sales before 1 a.m. and sales after 1 a.m. We have something like that. Then we can perform a paired t-test with a star mark in between. So here we should not be having anything like this. So it looks, this is a paired sample t-test, as simple as that. The syntax goes. Okay, let us not worry about paired sample. Here I am performing a independent sample. For this, what I am doing is, my requirement says verify using t-test if each store is set to sell one car extra by 2016 from what they have sold in 2015. Will the net total worth of car sales cross $200,000? Okay, so which is around 14% growth, a significant value at 90% confidence interval. Okay, so let us assume that how I am doing it is, uh, now I have calculated car sales 2016 data. Okay, here I am increasing the units sold by 1, and again I am calculating the sales by using units sold. And I'm doing so forget about the 200k deviation and all. Again, it is like a one sample t-test which we have already seen, but here what we are going to see is there any significant difference in sales per month by each and each store. So for making sure that at least one scenario to fail, I am not incrementing this value for store ID 103451 for the month of March, the third month. So I have just included a extra if else block. If the month of sale date is March and the store ID is 103451, then I am not incrementing it and I am not calculating the sales. So let us run this thing and perform a two sample t-test. So we got the output, and again the same way I am looping, but here I am not looping on store ID because I am performing the two sample t-test here. So two stores I can have it in the data set for each and every month. So I am just looping on the sale date. So 12 times the loop will be executed, and now I am performing a t-test with a class variable store ID. So that is the difference between t-test with one sample and t-test with two independent samples. So here I should not be having anything like before 1 a.m. after 1 a.m. and all. I am removing that, and sales value. So I am performing the t-test, two sample t-test. So first, before doing that, just generate this car sales 2016 data set. Now I got the sales also. Each unit is incremented by 1, and then I am performing a two sample t-test. So here I got a little additional details. Now the store ID is added because two independent samples I am comparing, which is for each and every store. And here I have to check for pooled differences because the independent samples and I am assuming equal variance. So equal variance is a pooled method. So I have to check the statistics of pooled pooled method of calculating the t value and p value. So here anyway, for both the cases I have the t value minus 0.47 and p value a probability is really high. So the null hypothesis stays good. So there is not much significant difference in mean value when I go with pooled or Satterwire uh, t-test. The means are not significantly different. So let us check the value for the month of March, because intentionally what I have done is um, for March month for store ID 103451 I have not increased the unit sales, so the mean is far less, and the mean for the other store ID is really high. So the t value is also obviously it is really high, so 3.36. Anyway, again as I have mentioned, our data is normal, so the variances are equal. So even if we can't pooled or the other method, we are getting the same t value and the p value. The t value is really high and the probability is very very low that there is a significant difference between means of store id 103451 and the store id 203476. So the null hypothesis should be rejected. Alternative hypothesis, which is there is a significant difference between the two means for the month of March on between these two stores. So as expected, if you look into the data, 3 point till 90% expectancy, like till here, no, the mean will not be falling under this particular area. We have to go beyond this 3 point um, beyond 3.36, which is around here. So it's almost equivalent to 99.9%. Only it is meaningless if we go with such a kind of confidence interval. So the more the confidence, we are adding more and more values into our population, which is really not feasible. So we have to go with alternate hypothesis, and means are significantly different. So here using today we have learned how to perform a one sample t-test and two sample independent t-test, and we have seen the syntax of a paired sample t-test. This is a hypothesis testing in SAS. So that's all I have for now. Thank you. Signing off.